Welcome to Pomodoro Joe for Thursday, October 12th, 2023. Today we're looking at LeetCode problem 1095. You gotta be kidding me. Find and mount an array. This is another hard problem. Dude, LeetCode, come on. This is the fourth hard problem in the past 5 days. You're killing me here. Okay, what do we have? It says this problem is an interactive problem. I don't know what that means, but we'll keep going. You may recall that an array is a mountain array if and only if array length is greater than or equal to 3, and there exists some I blah, 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 blah. Basically, it's just saying that you have a left side that is increasing up until some peak, some max value in the array, and then it decreases to the right side. So from the left to the right, it goes up to a peak, and then from the peak to the right, it goes down. That's a mountain array. Maybe I'll explain this better. All right, so a mountain array just means you have the left side is increasing up until you reach some peak value, some peak element, and then from the peak element to the right, it will decrease. So increasing, and then a peak, and then decreasing. That's a mountain array. So given a mountain array, return the minimum index such that mountain array get index is equal to target. What does that mean? Well, it looks like we're given a target, which is a target value, and this thing called a mountain array, which is not your standard list. This is a class that they've created. And we only have two things we can do with this class. We can call get, which will take an index and it will return the value at that index. And we can call length, which will give us the length of the mountain array. Okay, blah, blah, blah. All right, submissions making more than 100 calls to mountain array get will be judged wrong. Also, any solutions that attempt to circumvent the judge will result in a disqualification. Okay, so they're basically saying we can only call get up to 100 times, which means that we can't just go through the entire array calling get on every value. Well, unless it's a short array like this, it would totally work. Well, let's see how long of an array we might get. So it looks like our array is still pretty short, but it's 10 to the 4th, which would definitely exceed our 100 call limit if we just went through for every element and called get. All right, so we need a smarter way to do this. The first thing that comes to mind, of course, is a binary search. Now, a binary search is great when you have a sorted array, because with the sorted array, you can narrow down your search window. Unfortunately, we don't have just a sorted array here. We have a mountain array. So we're going to have to find a better way to do this. All right, let's put 25 minutes on the Pomodoro timer and we will get started. So let's start with some result. But what do we do if we don't get a result? Oh, here. If such an index does not exist, return -1. All right, so we return the minimum index where we can find the target. Otherwise, we return -1 if it doesn't exist. Cool. So we'll start our result. We could start it at -1, or we could start it at infinite, seeing if we can find something that's better than infinite. So I'll start with this. We'll start our result at infinite, and we'll return our result if result does not equal infinite. Otherwise, we'll return -1. All right, this way, if we find something that's smaller than infinite, that's a real index that we could return. And if we don't find something smaller than infinite, then we will return -1. Okay, so how do we approach this? I don't really know. So since I don't really know how to approach this, let's see if we can break this down into problems I do know how to approach. Now, I do know how to approach this problem. If it were a sorted array, I can do a binary search on a sorted array. Okay, so that's one thing we could do. It's not a sorted array though, it's a mountain array. But what's nice about the mountain array is that the mountain array is really kind of two sorted arrays that are back to back. You have from left to the peak, that is a sorted array in ascending order. That's your first sorted array. And then you have a second sorted array from the peak to right that's sorted in reverse order or descending order. So if I know where the peak is, then I can break this into two problems I know how to solve. I know how to solve the left side, an increasing array sorted in increasing order, I can totally solve that. And then I can do the same on the right side. It's a little bit trickier. I'll have to flip my thinking, but I can also solve a binary search on the right side, a decreasing array. So the key here now is to find the peak. I need to know where this peak is in order to figure out the two arrays that I can do my binary search over. So let's find the peak. So let's call this step 1. Step 1. Find the peak. All right. I don't know where the peak is, so I'm just going to pass on this for now. That's going to be a tricky problem, but let's say we find the peak. So let's say we have some peak. I'll just set it equal to 0 for now. Once we find our peak, then we'll go on to step 2. We'll find the index in the left side. All right, so the left, I'll call it left sorted array. That's from low or from 0 to peak. Cool. And then if we do that properly, we can also do step 3, which will be finding the index in the right sorted array, which will be from the peak to the length of our array. So that's from peak to max index. All right, so maybe we should grab this max index. Let's do that. All right, so now we have this problem broken down into 3 steps. Step 1, find the peak. Step 2, find the index in the left side array, the ascending ordered array. And if that fails, then we find the index in the right side from peak to the max index. Cool, this is starting to take shape. All right, so we don't have this max index. Let's grab that first. All right, so max index, well, that's going to equal this mountain array length minus 1. So this is a function we have to call on the mountain array. So mountain array.length minus 1. That gives us our max index. All right, let's see, which should I do first? Solve the peak problem or solve the sorted array problem? Let's go ahead and solve the peak. Why not? Okay, so to solve the peak, this one's tricky because typically with the binary search, you'll split our array into 2 halves. You'll have a high index, a low index. You'll find the middle index, check to see what's our middle index relation to our target. Now in this case, we don't know our target because the target is this peak. We don't actually know what the peak value is. Well, one thing we could do is we could find the middle index. And then we could look at either the element just before that index or the element just after that index. Now, if the middle index is the peak, then it will be greater than both of those elements. If it's not the peak, it'll either be less than the element before or greater than the element before, which means that we can figure out the slope and we know which direction. If it's got a slope that's going up, the peak must be in that direction. So let's do that. Let's find the peak by finding our slope. All right, so we have some low index, that'll start at 0. We have some high index, and that's going to start at the max index. And then while our low index is less than our high index, so this is very similar to a binary search. So while our low index is less than the high index, let's find the mid index. That's just going to be the low index plus our high minus low, and then integer divide by 2. So we're going to find how many elements are in our search area. We're going to divide that by 2. Then we're going to add it to our base to find this mid element. All right, now let's see. We need to find our slope. So if the mountain array dot get, calling get is scary because we only get 100 of these. All right, so the mountain array dot get for this mid index. Let's see, we can either go for the element just before or the element just after. I think I'll go with the element just after. So if this is less than the mountain array, dot get at mid plus 1. All right, that means our slope is increasing up to the right. So that means we need to change our low index equal to mid plus 1. So just to go over this one more time, we're grabbing the element at the midpoint, and we're checking that value against the element at the one just to the right. Now, if that happens to be less than the element to the right, that means the slope is still going up and to the right. So our low, we know that our peak won't be anywhere between the low and this midpoint, but this midpoint plus 1 could be our peak. So we'll actually move our low up to this midpoint plus 1. Otherwise, we can move our high down to the midpoint. This is very similar to a binary search. All right. Now, at some point, our low and our high will converge, and at that point, our low will be our peak. Awesome. So actually, that means this peak that I created out here, this will be equal to our low. Okay, so we found the peak. Now we have to do our binary search. Now, in this case, our binary search will just go between 0 and our peak. That's our left side or increasing array. So this is our standard binary search. So we'll just say low is equal to 0, high is going to equal our peak, and then while low is less than high. Very similar to what we just did. We'll find the midpoint, that's going to be low plus high minus low divided by 2. All right, now we have to do some more of these gets, which it's kind of scary, but we got to do it. All right, so we'll get the value at this midpoint. So if the mountain array dot get at this midpoint, if that is less than our target, that means we're still looking for our target. The target must be above this midpoint. We'll move our low up to this midpoint plus 1. All right, otherwise we can move the high down to the midpoint. Very similar to what we just did up here, but now we're doing a binary search checking for the target. All right, so if we make it through all of this, if our low, so we've converged, our low index should contain our target if the target exists in this half of our mountain array, or in this first segment of our mountain array. So if mountain, this is another get. So if the mountain array.get at this low is equal to our target, we just found our target. So we can return this low. That's the index where we found the target. And since we did this on the left half first, that means this index has to be lower than if it exists in the right half as well. This one will be the lower of the two indices, so we can just return the low right here. Awesome. And that kind of makes me think we're not going to need this result, but let's keep going. All right, so if we didn't find it in the increasing array from 0 to the peak, now we have to look for it in the decreasing array from the peak down to our max index. So we'll have some low. Now, I'm still going to use low to indicate the low index, not the low value. So this is the low index, which will be a higher value than the high index, which will be the lower value. Confusing, but I think that helps me reason a little bit better. All right, so our low is going to start at the peak, and our high is going to start at max index. All right, and then very similar. So while low is less than high, since we're still using the indices low and high are, relative indices left and right, we'll still do the same thing. While low is less than high, we'll find the midpoint. That's just going to be low plus high minus low divided by 2. And now we'll do the same thing. We'll check if this, let's see, I guess our check might be a little bit different. So if this mountain array got at the midpoint, so previously we said if it's less than the target, now I'm going to say if it's greater than the target. All right, so if this is greater than the target, I'm flipping my thinking around. Let's see. So the mountain array at the midpoint is greater than the target. That means we need to move our high up to our midpoint. This is confusing. So let's see. We've got a midpoint. the midpoint value is greater than our target, which means that our target must be between the midpoint and the high because this is decreasing. So that means we move our low index down to the midpoint plus 1. Otherwise, it means that our target must be somewhere between our midpoint and our current low. So that means we move our high equal to our midpoint. Okay. And now we do something very similar. If we have this target at our low, we can return low. So same thing here. And then if we didn't get any value, like if we didn't find it in here and we didn't find it in here, then we return -1. So I actually don't need this result at all. We can get rid of this result to save us a little bit of space. Okay, so I think this should do it. We took this mountain array, we broke it into 3 steps. Step number 1, find the peak. And we find the peak basically by finding the slope. Once we find the slope, we can figure out if we need to concentrate on the left half or the right half of our split. Then once we found the peak, we can concentrate on just the left part, meaning from 0 to the peak, do our binary search, and then concentrate on the right half or the right part from the peak to the end and do our binary search. If we find the value in the left half or the left side, then we can return that index because that has to be the lowest index. If we find it in the right side after that, then we return the right index. And if we don't find it at all, we return -1. Man, okay, let's see if this works. Okay, it seems to work. Let's see if this will pass all the tests. Oh, and we pass. And we do, whoa, we do really well. We beat 98% for runtime and 80% or 60%. 60% for memory. Whoa, that's crazy good. I did not expect it to be that good. All right, well, I'm pretty happy with that. Okay, so we took this really hard problem and we broke it down into smaller problems that we do know how to solve, things that we've seen before. Maybe not finding the peak, but we've done things similar. So, broke the problem into smaller problems, find the peak, concentrate on the left side, and then the right side, find the first index that has this potential target value. Okay, well that is it for me. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.